Hello, everybody. My name is Chris Berg. I'm CEO of a company called DataKitchen. And, as was said, we focus on something called data ops. And so what I'm going to do is kind of start talking just at a high level about sort of what the heck is this data ops thing, and then kind of go into a demo, and I'll do a few slides ahead of time. And so, one of the interesting things about data and analytics, and I spent 15 years writing software and then 15 years running data science and engineering teams, is I think all of our customers in analytics love Amazon, and they love it not because AWS or Jeff Bezos does rockets. They love it because they can get a package the next day, and they can subscribe to Prime. And the reality is the kind of packages of insight that we're delivering in analytics, it's as if we're shipping the wrong product and it's arriving in a box that's all torn up and broken. And our customers are looking at it going, this is crap. This is not what I wanted. It's broken, and can you change it? And then we're taking, weeks to ship them a new version that also may be broken. And so how do we go from kind of a subscription experience where our end business customers or end consumer customers can order something overnight, and they want insight overnight, and they want it perfect, they want it on time, and they want to be able to, change the order at the last minute. And so it's hard in a data-driven world. And so the perspective that we have at DataKitchen is that the focus should be on a different thing. It shouldn't so much be on the things that you do. So it shouldn't be focused on, hey, here's the cool model. It should really be focused on the system. And in a lot of ways, data and analytics, we kind of focus too much on the car, and we should focus more on the factory, because the factory that produces the car actually has a huge determinant of whether the car works or not, or whether that car can be delivered. And so likewise, there's another part of, we all have problems in data and analytics. And when there's problems, we should be looking for the common cause. We should be looking for what aspect of the underlying system can we improve. And when I use the term system, I don't necessarily mean hardware. What I mean is the sort of people and process and how we work to make that done. And so what's interesting, and sort of goes with my career, is that, I spent a lot of time thinking about, okay, what is the right data science model, or what's the right algorithm, or how do you arrange data in a data pipeline? How do you visualize data? How do you govern it? Well, what's the data like? And all those things are amazing, right? They're not to say that they're not important, but actually I've come to believe that the system that you work in, the processes you work in, how you develop, how you deploy, how you monitor, how you iterate, how you collaborate, and even how you measure that work itself is actually more important. And so there's this really contrarian perspective here that says, don't focus so much on your tools and technology or even your data. Focus on the process and the people and the operations around that. And if you get that right, you're going to be much more successful. And that's really kind of what we're going to talk about today. And we're going to focus on kind of four things, because that may be a bit fuzzy to you. And so one of the four things that we're going to focus on is talking about this thing called error rates. And that's one aspect of the process. And the second is cycle time. And those two things for a lot of organizations are completely opposite. And what I mean by errors are the data's wrong, you're late, you're not meeting requirements, something broke during the production. How do you get that down so that your customers trust you and trust the data? And then cycle time is what I really mean by that, is how fast can you get something from that smart person that you just hired, that data scientist or that data engineer, how fast can you get it from their brain through their keyboard into the eyes of your end customer? And I think that's also a really important point. And a lot of people think that those have a big tension in it, and they're right. How do you do both at the same time? And then how do we get away from the Hatfields and McCoys? Oh, it's not my fault. And then how do you actually, as a leader, measure your process? And so for us, we've taken this term and called it data ops. And now some people call it model ops, or there's a bunch of terms out there. And, even Gartner has started to use the term XOps, and I don't particularly care what ops you put on it. But the idea is that there's a set of technical practices and kind of cultural norms and architecture patterns that really focus on these four things. How fast can I deploy? Once I deploy, how often is it breaking? How well is my team working together, and how productive they are? And not just my team, all the teams involved in the value chain and analytics. And then as a leader, how can I show my value? How can I measure all this stuff and say, look, I am making an improvement, productivity's up, error rates down. we're getting more value out to the customer. And so those things are what we're going to talk about in the demo. And unfortunately, if you were to take a sort of a graphic equalizer and look at, and we've done surveys with Eckerson and other analyst groups have done it, is it really takes a long time to deploy things for a lot of companies. And we're not talking hours, we're talking months. And I've run into companies with a lot of pride saying they only have one major data error now once a week. And I just think that's unacceptable. And so how do you take that graphic equalizer and sort of push up on all four of those levels? And that's what we're going to talk about. How do you do that and not sort of kill yourself and break your team? And what are the benefits? Like if you push up on all those, at least what we have seen is that you actually deliver more insight of whatever form, models, visualizations, with less errors, and your team is actually more productive. So it's an amazing kind of story that by focusing on the system, the people in the process, you actually get much better results. And that's sort of our discussion today, and where we're going to highlight it in the product demo. We're going to focus on error rates. We're going to focus on cycle time. We're going to talk about collaboration and then measure the process. And so that's kind of the first part of that's a setup. And then I'm going to sort of walk through in our product these steps. And how do we want to do this? Just jumping out of the discussion. Do I want to wait and ask questions, or should I just keep plowing ahead? How do you guys want to do it from Great Data Minds? Well, with no lack of feedback, I'm just going to plow ahead then.
Sorry, Chris. Mike, as you could see, we had a little bit of technical difficulty, so we were on the back end working with him, but he's coming back in.
Okay. And I'm just wondering, do you want me to stop and ask questions, or should I just kind of plow ahead into the demo?
Know what, Mike and I can moderate the questions on the back and then hit them in the end. So, leave about 10 minutes.
Okay.
About 20 till we'll start hitting those questions.
All right, fantastic. So this is our product, and we're called DataKitchen, and this sort of graph of steps in front of you is what's called a recipe. And what's interesting here is this is all, think of it as an example of all the steps you would likely do to get value out of data. So you source it someplace, you transform it, you put it in a data science model, you visualize it, and you put it in a catalog and govern it and put security on. And in general, we kind of do all these things. Now this one is it's a system that doesn't actually touch the data. We're touching the tools that touch the data. So in this case, there's an ELT process.
Chris?
Yep.
Are you showing something?
I am, yeah.
No, we always see your beautiful mug.
Oh my goodness. So I thank you for telling me.
No worries.
I've been showing stuff the whole time. Let's see, there we go. How about that? Is that a lot better?
Mm-hmm.
I had some great slides too, so sorry folks. And sorry for the screw up here. So the great slides that I had involved, I'll jump back to them later. But really what we're talking about is kind of, to go back, we're talking about how you develop a system using any of your tools that runs with low errors. So you don't have to learn about problems from your customers. And to do that, I'm going to show our product, and our product has all these steps in. And so it's this graph, and what I started to talk about is all these circles are kind of, think of them as the tools that you use. And now this is an example that runs in Amazon that happens to do an ELT transform against a Jupyter notebook and Tableau and kind of a cheap and cheerful data catalog that's running out of a wiki. But you may have you may have your favorite ETL tool like Informatica. You may like to use SAS. You may like to run in Azure. You may not like Tableau. And so in general, the tool chain that people use is as varied as the company. And so what's important is that how do you run all these things so that you don't get that sort of nasty email on Friday afternoon from your VP saying something's wrong. And then you've got to kind of call up your wife and put your tail between your legs and say, I got to spend this whole evening figuring out what the problem is. And then and it's not fun. And so how do you avoid those errors? And I think the most important thing is these numbers that we have on here. And these numbers indicate, think of them as tests or monitors. We actually go in and grab bits of data and grab things that are produced from the data. to see if they're right. And so it's important that you know that when you're doing your data and analytics, that it's right before your customers do. And so to do that, you can't just sort of hope that things work, especially in these complicated systems. And so each one of these numbers represents what we call a test. And so let me show you an example of what we mean by a test. And so this is the last part of the ELT process, and it's called check facts. And so what we're doing in this is we're checking to see that the fact table that's created is right. Now, you may not even like fact tables, you may not like SQL, but I like Kimball and I like SQL, and I wrote this demo. And so here's some SQL statements. Now, I'm going to show you ELT. I'm going to show you some Python, different ways that people work with data. But in this case, the group has suggested that they use SQL as a way of interacting. But as the SQL is running, what we're doing is kind of grabbing little bits of data. And in this case, we're just doing a really simple check. Is the number of count of the fact table the same as the staging table? Like, are there any losses along the way? And I think that's, a really important test, right? Because sometimes things happen along each step in the process. And what we do here is we can check by numbers, you can write equations, you can do something called statistical process control to see that it's right. And we're going to send you an alert if something's wrong. And I think that's actually really important for a lot of teams to focus on reducing errors. And what happens when the system runs, we create something called an order run. And that order run is the sort of metadata about the processing that happened. And you can see that all these steps worked. And in fact, you can even look at all the tests that happen. And so here's a list of all these tests, and some of them have to do with the data, and some of them actually have to do with the forecast model. So for instance, is the predictive model that's doing the forecasting right? And here we're looking at the root mean squared error of the machine learning model. And so we're trying to check everything, including the results of Tableau, because as this system runs, we want you to know that it's right. And we want you to know that it's been done on time. And we want you to be able to see the results of each test. And so what you can do is kind of click in and say, okay, here's our forecast model, and here's all the tests that ran, and here's the test results that happened. And so think of it as your insurance policy, right? You may not, in your company, you may have one of these production jobs running, but in most companies, there's lots of them, and they're running all the time. How do you know that it's right? How do you know that things are going to work? And how do you not end up having problems? And so the theory behind this, and the theory that we put in the software is, look, just don't hope things work, right? Automatically in production, check and test and observe your systems to see it right. And not just look at the CPU, look at the data itself, and do it across every one of your tools. And if something looks weird or something is wrong, send an alert. And if something's wrong, sort of stop the production line, give your Toyota-like virtual andon cord. And then actually keep track of history, because that's a really important part of being able to do testing, because sometimes if you've gotten a million rows and a million rows and a million rows and then a million rows, this next time you've got a data set, you've got 300,000. Is that right? Did they forget a file? You just want to know, right? You don't want that to go off to your VP and then they call you up and then Friday afternoon you're scrambling. And do something called, that's really an example of using history to be able to create value. And make it easy to create tests. And so don't give people yet another tool, allow them to do tests in their own language. And so there's a lot of ways to think about monitoring and testing data. So you may have a profiling tool that you get in your static data, you pour it in and it tells you, okay, this column's got 3 values. That's a test. There's the statistical process control tests that I talked about, the location balance test. And one, I don't know if you've had this experience, but like I've gone off, got a new data set, taken a data scientist and an data engineer, and we've worked on it and put it together. And a couple of weeks later, we present it in front of our customer, and they're all happy to see it. And then like in 2 seconds, they snap their finger and they go, bam, the data's wrong. And you're like, how do you know the data's wrong? Well, because business people look at data from a business perspective. They look at it from their top customers, their top regions, their top products, and they remember values from the last time they see it. So make tests that are based on the business domain, make heuristic tests, make what we call historic balance tests. Look at the top products, the top regions, and compare them from the current time you've seen them to the previous time. That way you know if it's right. And so why do all this work, right? Why build all these tests? Well, having low errors, we think actually leads to more innovation because you're spending too much time reacting to problems instead of innovating. And it actually leads to more customer data trust. And I think that's not a small thing. And even the last two things, having less stress and less embarrassment, I think is a good thing. I don't think we have to sort of wear the hair shirt of like, we're going to suffer and react on Saturday morning or Friday afternoon when things goes wrong. I think we can build a system that tells us and we can know before. And if you have all this, it, invariably, things are going to happen, right? Some provider, some test is something's going to happen that you didn't predict. And it's so much better to say to your customer, yep, we have 1,000 tests in production. Yeah, we let some bad data slip. We know why. We're going to put in a test so it doesn't happen again. And I've never seen a business person not understand that and being able to fall forward. And this whole idea of automated testing and monitoring on top of your system is a really powerful idea. And it also helps the next part of my demo, which is really like, how do you change things? Like, how do you get stuff from development here in the bottom into production at the top? And what's that process that allows you to do it? And so let me see, I'm going to just see if there's any quick questions I can answer along the way. So I don't see any. Okay.
Yep. Chris, we had one.
Oh, sure.
Andrew said, what does implementation look like?
Well, I think, there's a couple answers to that. So the first is that our system doesn't magically create tests for you. So if you've got a chain of tools that you have, we've got a lot of connections and integrations to all the major tools, and they plug in our system. But you've got to sort of write the test yourself, because I think you need the domain may be different from manufacturing to drug discovery, from financial services and banking versus brokerage. And so that's a big part, is like what tests work, but it's not hard. You just got to start writing tests and plugging them into the system. So our implementation process tends to kind of follow 3 steps. One is we get the technology in there. 2 is we start to work with companies to help understand, well, what kind of tests do you write? Where's the value you want to do? And then we work to add the tests and the monitoring slowly into your system. And so that can take, take some time to get going in big customers. But in general, that's the idea, is if, tests are your friend, tests are the gift that you give to your future self. And so convincing your team to write tests and providing a framework through our software that helps do it, I think, is the way to go. All right, so let's keep going. Let's talk about this other thing, this idea of like, how do I get stuff from all these smart people I hire, data scientists, data engineers, from their brain into production, and how does that all work? And so that's generally a deployment process. From here, some form of development environment through a series of steps into production. So it's this up and down access. And like an example that we usually go through here is to say, well, let's say you got a VP of marketing, and there's a data engineer and a data analyst, and that data engineer happens to use Pentaho, and it could be Informatica or Talent or Airflow, and it happens to be Tableau, but it'd be Click or Power BI, and it happens to be Amazon, but it could be on-premise or AWS or GCP. And so there's all these steps that they go through to do it. Data's persisted, it's transformed in an ETL process and visualized. And so, how do you answer this question, right? Your customer says, I want something tomorrow. And when I have managed data engineers and data analysts, I thought my job was to protect my team. So I go to that business person, I'd say, features, time, quality. You get to pick 2, not 3. And we'll write you a spec and get you a first version in 6 weeks. And I would leave that office, and I'm tall, and I often thought the person was looking up at the back of my neck going, hey, you big dumb nerd, why can't you do this? I need something tomorrow. I think it's reasonable to say, can we get them something? And the trade-off here is it's not perfect. It's 70% right. Maybe it's 70%. You can 70% trust the data. But getting something imperfect in the hands of your customer quickly and learning from it is so much better and saves you so much work, because you learn what's really matters to the customer, and they can see it and touch it and feel it. But you want to do it in a way that doesn't kill your team and doesn't create a data governance mess and doesn't just doesn't create what's called technical debt that you've got to fix later. And so how do you do that? And so the example I'm going to talk about is, well, if the person wants a segmentation, well, we've got to get the cool person involved in their sort of Steve Jobs turtleneck. They got to come in, the data scientist, and be able to sort of write a model. But some cases you can change one tool, but a lot of times in data and analytics, everyone's got to get involved. The data engineer's got to add a column or two. The data scientist's got to put in their model. This is a batch scoring model. And then the data analyst has got to actually change the charts to show it to that VP marketing. So all these people have got to work together. And so how does that work? Like, who does what and when does it happen? And more specifically, where does it happen? And how do I know that it's right? And so what I'm going to show you is something, again, using a food metaphor called a kitchen. And so I'm going to work in that kitchen, and all my people are going to be involved, the data engineer and data analyst and their tools and their test data, and they're going to be able to do all their work in there and add it. And most importantly, see that the new stuff works, but also see that they haven't broken anything else that already runs. And that's a really important point, because you don't want to have what are called regressions. You want to make sure that things work. And then you want to be able to sort of push a button to be able to get it into production. Because you want to have some control on that and be able to have some rules about it, but you want to be able to deploy it. And so we're going to show that in the product here. And to do that, I'm going to go and change the customer that I usually do this with to our demo customer. And I'm going to go to a different kitchen. And this one is called production. And this is our production kitchen. And I'm going to show this. And so I'm going to go look at this recipe. And this is a really super boring recipe. It's got 5 what we call nodes in. But the first node actually works with Pentaho. And so I'm going to drill into that and kind of show you. And if you remember the other part of the demo, I showed you SQL. Well, this company doesn't like SQL. They like to use nice visual tools like Pentaho. And when you use a nice visual tool like Pentaho, the work that you do is represented as these files called KTR files. So we actually keep those KTR files as part of our recipe. And then we run them and we push them into a Docker container in a Kubernetes cluster. Now there's different ways that we address it. It could be through SSH, or it could be in a container or not in a container. It could be hard installed on an IP. But in this case, the Pentaho engine runs in a Docker container. So we run it and we say, okay, here's some data, run it, and we're going to get some test results. And here's a really simple test result. It's just is it greater than 10,000? And that's all that we have to do. And then when the system runs, it creates that order run like we saw before. Here is, did it work? Yes, it's all green. The number of tests ran. And so here's the result of that running that Pentaho test. So I'm also testing Tableau. And why do I want to even test Tableau? Isn't that just a BI tool? Don't I have to? Well, it turns out that almost every tool in data and analytics is kind of a little development environment. As an example, you can build a calculated field. You can build an if, then, else statement in Tableau. And to me, whether that if, then, else statement is in Tableau, whether you've put it in Python, whether it's in SQL, or whether it's in some script, it's still code in the software engineer sense of the code. So I want to make sure that that's right. And especially what happens is that if then else could determine what's in a nice chart that goes to your VP. And if you have a data set coming through where the third part of that if then else statement is suddenly 0, you want to know that before your VP knows about it, because he or she's going to call you if it's wrong. And so that's why we want to make sure that we test Tableau, because sometimes that the data may be right, or the data may be wrong, but that if then else is causing a problem, and that if then else only happens to be in Tableau. So test the data that actually gets put into Tableau and test the result of it to make sure that there's no problems. And again, that's what happens in production. So now we want to do that challenge. We want to be able to say, how do I make a change? So I'm going to go to my production kitchen and I'm going to create a child. So I'm going to create my test environment. And so if you think about it, well, what does it mean to have a sandbox? What does it mean to have a place to work? And the first is that you've got to have your tools, because some companies have one tool, some companies have 10 tools that they use to do their data science or data analytics work. And then those tools, you've got to have the right versions, the right libraries of them. You've got to have hardware that they can run on, and you've got to have test data to make it work. And so in some cases, that test data may be exactly what's in production. And other cases, it may be a subset where you've taken out all the personally identifiable information and GDPR rules. But in either case, you need all those things. You need test data, you need hardware, you need software, all the tools that work, so that it's just like production, but not quite. And in some cases, that environment happens to be fixed, like it's a server and I need to use my dev server. Or in other cases, you may have happened to transition to the cloud, and you know what? You don't have to have a server. You can turn a server on and what's called spin it up. And in other cases, you may want to have people. It may be just the three of you working, or 10 people, or maybe just yourself. And so it's a place. And so you invite people. And then when I started my career, I worked at NASA Ames, and this is 1990. My branch chief would use this phrase. He said, build a little, test a little, learn a lot. And I think that's like really profound engineering wisdom. And we want you to, in a kitchen, build a little and test a little and learn a lot. So we scope the orders to the kitchens, but we also give you a bunch of variables, which are kind of like control knobs. Because in production, a lot of our customers have these recipes that have 10 tools and 150 nodes, right? And that's just too complicated to run. You want to zero in on, maybe I just want to run the middle part. 3 nodes in the middle that I'm only focused on, and we're going to give you some controls to do that. And then lastly, we think one of the most important part of data and analytics is that there's a there, that the work that you do lives in one place. And we think that repository should be Git. And you should be able to branch it, which means create a virtual copy of it. And so that virtual copy and that Git branch happens along this. And so let me show you what that looks like. So I'm going to create this kitchen. I'm going to call it Devsprint. And build a little, test a little. I want my alerts, my warnings and failures just to go to me. I don't want them to go to the production team. And then I'm only really interested in this one recipe, not the other ones. And then partly there's a role that we don't have time to talk about. It's like, well, what is the environment you work in look like? Is it on Azure? Is it on Amazon? Do you have to start up a new database, use an existing database? Do you need any EC2 instances running, et cetera? And so in building this demo, our data ops engineer gave me a couple options. And one is I could start a new Redshift database from beginning. But the other is I'm just going to create a schema in an existing database. So I'm going to create that schema as kind of a partition in the Redshift database. But I also have to create a partition in another already running system, and that's Tableau Online. So I've got these 2 servers. I'm going to create these places in them to do development. And so that schema, those partitions are what I'm building here, and that's what I'm running. And so I'm going to hit next. And because we're dealing with your infrastructure, that means we've got to have your credentials. And we don't want to have your credentials. So we store them all in an encrypted vault and kind of call them by reference. But some companies don't want developers to have any access to production. So sometimes you can have a completely segregated vault from development, and we allow that here. And so I'm going to go off and just create a kitchen. And so I hit this button and it goes off and creates the kitchens for you. And so this is an example of how we're trying to make it easy for people to set up the environment. And so if I go back to that kitchen, I can kind of see I'm in this kitchen on the upper left called Devspring. I only got one recipe now, not the whole list. And I can do my work. I'm in a safe place. I've got test data. I've got my partition servers. I'm on a Git branch. Fantastic. I can go ahead and do whatever I want. And so in order to save time, I've actually kind of prepared this ahead of time. And so I'm going to click into this and I'm going to make one change. I'm going to say, instead of today, I'm going to say great data mines. I'm going to change the description of this. And what happens here when I hit update is this actually goes in and just makes a commit on Git. And if you go into Git and look at it, you'll see a commit. And so your data scientists would be using their tools. They'd have their Jupyter notebook open, and they'd add a node into our system. And we have different types of nodes, some of which can talk to specific tools, some of which are ways to talk to databases because you may prefer to do ELT, some of which are ways to make reusable components that we call ingredients. You can start from templates and reuse nodes, but the data scientists added their node in, and they put in this Python Anaconda segment. So they added the node in, and they did their work. And of course, their work ended up being an IPython notebook here. And here's the IPython notebook. And so here's that k-means cluster that happened. And so they did their work in this notebook. And so if I go back and to the variation and look at it, I can see that all these steps are here. I can see that all my changes. So data engineer added their column, the data scientist added their notebook in, and the people added their the changes to Tableau. And of course, there's tests on it because we want to know in development that this works. So because I'm in my development environment, I can just run this, and I don't have to worry about kind of bumping in to anyone else. I can run this, I can hit agent, see the status of my agent, and I can then look at kind of all the variables that are applied to this. This is kind of maybe a nerdy thing for some people, but you got to deal with passwords, right? And you want those passwords to be secure and changeable and in one place. So we actually give you a variables that you could call password, and then we reference it by vault. So we pull it out just at the last minute. And that's a good thing. We filter it out from the log files because sometimes some of your databases actually accidentally put credentials in the log files when there's an error. And so we take this and it runs. And so another way to think of our recipes, and this is also if you're more of a nerd, you could say, I don't like using your UI. I want to just use a command line. Well, go ahead. All this recipe itself is all just a command line. And here's all the files that run. And so you can edit the files in our UI, or you can go in and pull them down to disk and use our command line to interact with it. And so there's just different ways and different aspects that people use our system. There's command line people, there's UI people, there's a whole REST API that you can program against. And so if I go look at the orders, I can see that this order is active and it's running. And so let me see how it's going. So each one of these steps is working. So the data is being transformed and Python Anaconda is running. And you can kind of see each one of these steps going and proceeding. And I think one of the most important part here is these tests. And so I'm actually in development. So I'm in a development environment. And now I'm adding this new test, this Python Anaconda segment. So that new k-means clustering I added, it works, right? Hey, I've proved that it works in development. But I'm also rerunning the existing tests that happen. And they have kind of a different purpose. So notice I'm actually running this Pentaho test again, because I want to make sure I didn't break anything that already exists. And in a lot of these big technical distributed systems, you're making changes on this part in the middle. And how do you tell if everything is still working downstream? And unfortunately, we've been trained as data engineers and data scientists to put our blinders on and say, okay, I've done my world. It works. And maybe I've done a unit test, which just tests my little piece. And I think that's good, but it's not enough. You need to take your blinders off. You need to see the whole system. And you need to see if my small change affected the global system. And only way you can do that is to actually run the whole system from your desktop in a development environment and see that all the steps work. And that's what happened here. We're going in and rerunning all these steps to see that they work. And I think that's a really important concept here, is that we kind of live in a world where we're focused solely on pulling the work out of your task list and getting it done. And then you kind of throw it over to somebody else to worry about it. And I think it's a really important part of everyone's job to worry that, hey, is the change I made going to affect everyone else? And that's where you've got to be able to have tests. You've got to run them in development as well as in production to see if it's right. And so let's do the last thing. How do you actually get this from production into development? And so I'm going to go to my kitchen list, and I'm in this Devspring kitchen, and I want to get it up to production. Now, some organizations have very stateful infrastructure. I have a dev server, a UAT server, a QA server, a pre-prod, a prod, and you've got to kind of do patch scripts to move things from one to the other, and we support that. Other organizations have, instead of having stateful systems, they have more functional systems where if they put some new code from one environment to the other and they rerun it, the system will have that new code available. And that's the way that we did it. And so I'm going to actually take the dev sprint work and I'm going to merge it up into production. So I'm going to merge it from dev sprint to production. And here's this really dumb change I made to say great data mines. And I'm just going to do a git merge. And I want to get rid of my child kitchen. And yeah, I know I'm going to get my child kitchen. I'm going to do the merge. So I'm going to take that work. It's going to be available in the production kitchen. And so if I go now that I'm in the production kitchen, I can see that history and that silly change I made. And so, I guess, why do you want to care about all this? So why does it matter to make it easy and fast? Well, I think the idea of agility is that if you get things quicker from the minds of your very talented and very expensive people into your customers, you learn more. And if you, instead of taking weeks or months, you can do that in hours, instead of making it really hard and really error prone, you make it easy, your team actually ends up delivering a huge amount more value. Because, yeah, you know, I like to go off for 2 or 3 months and write code. I know that that's not the right way to doing it, but it is kind of fun to like go off and build your own world. But you've got to sort of force feedback into your data scientists, your data engineers from your customers, because it's so hard to know what they want. And I think that's a really important part of the value, is just being able to iterate quickly. And you know, I have a little bit to talk about sort of collaboration and measurement as the last parts of the process. And how am I doing? How am I doing on time?
You're doing okay. You've got,
Okay.
you know, about 10 minutes to wrap, and no more questions have come through.
Okay.
So you're doing a great job.
All right. So let's go to this collaboration thing. And what do I mean by that? Well, let's talk about 2 cases, right? One is where everybody's on the same team and have the same boss. And then let's talk about the other case where people are on different teams and have different bosses. And so it's a little bit easier with a system when you have the same team and the same boss. And I'm going to go back to our kitchens as an example here. And so in this case where I've got some people are working on something in Snowflake, and we've got a kind of a development kitchen, and Priya and Tom are kind of working on their own feature. And that's fine. They're working on their own feature. Maybe Priya's working on one part of the ETL process. Maybe Tom's working on the model or another part of the process, but they get to work in their own kitchen. And they're working independently of each other. But the work actually has to go together up into Snowflake, you know, and so what we do is have another intermediate kitchen that kind of forms as an integration kitchen, where Tom can merge his work up, Priya can merge her work, and we can see if it all works together. And then we can actually get it into production. And so this is very much something that software developers figured out, and it's supported by version control, and why you want to do version control, so that you can each be on your own branch and then bring those branches together. And then also having kitchens combined allows you to manage the environments. So the development kitchen is this, so everyone's data sets, their test data, their hardware and software is all alike each other. So that way it removes the friction of people being working. And so that's just one case of like, how do you get 2 people who work for the same team? The more complicated case is where you have people who don't work for the same team. And how do you deal with that? And so we've all heard about self-service analytics, self-service data prep, self-service data science now. And what we've ended up with is where there's kind of a division in people. And so you have, in this case, and the example I'm going to show you is what's a home office, and they happen to use SQL Server and Python. They're in Boston, and they're, you know, developing models, building databases, and they're pretty, you know, agile. They work on a sort of a weekly cycle of change. But then there's these people who are around the country. Maybe they're in New Jersey or California or Chicago, or all in different places. And they've got some stuff on their desktop. They've got this tool called Tableau, which makes easy charts and graphs. They have Ultrix, which actually can get data and prepare data. And their cycle time of working could be an hour. It's like, hey, the VP said something. Can you figure this out? And they're like, yeah, I'm going to go do it before the meeting. And I think that's great, right? They're discovering the requirements. They're learning what works, and they're making the VP of marketing satisfied. However, it's not perfect, right? Because what happens is if something goes wrong, the VP of marketing doesn't know if it's that local office team or the home office team or even the source data. That's the problem. And if the home office team makes a change in a schema, how can they tell if they've broken the reports? They have no visibility on the reports. And in a lot of cases, the self-service team has little small data sets that they're mixing in to a bigger data warehouse. How are those available for all? How are those governed? How do you know that they're not? And then a lot of times, and if you talk to people in data and analytics, they hear this problem of like, I've got, you know, I don't know, my market basket, I've got 3 versions of the same calculation, my competitors, and there's same report giving different information. And while there could be different reasons for that, one reason is just you have, you know, a lot of times in self-service teams, instead of They work very quickly. They find something that works, and then they email it. Here's the Tableau workbook. I'm going to email it to you. It's emailed to someone else. And pretty soon you got 10 versions of the same workbook, and they all have that same calculation in. And then someone changes it a bit, and another one changes this. And so you've got 3 different versions, 3 different workbooks with 3 different versions of your market basket calculation. How do you make sure that those are consistent? And just like, how do you work? Like, how do you work when you've got a home office team and a local office team? If you want the data ops assumption that you should be able to change them quickly and you should be able to run with low errors. And so the way that we do that in our software is, of course, we use kitchens because we're DataKitchen. And I'm going to show you a different kitchen here. I'm going to show you this home office kitchen. And in this home office kitchen, there's a recipe that sort of spans both. And it's a home office one and a local office one. And what's interesting about that is these actually encapsulate what already exists. So there's a home office ingredient and a local office ingredient. But if I drill into this, I can see that there's a recipe that is owned by the home office. And in this case, it does creates a star schema using SSIS, which is Microsoft's on-prem ETL tool using SQL Server. So again, we're coordinating all the tools, we're running them with tasks, but this is the home office work. They're building the database and actually even doing some segmentation on the end. Great. That runs, but how does that work back with the other part? Because here's the local office, and they're running it. Now they're doing a different tech stack. They've got this one where it's an Alteryx workflow, pushing it to a Tableau project. And so the only way you can coordinate these things, because it's a really interesting case of how you coordinate, because it's kind of like the federal government and states' rights as a metaphor. You know, the states want to have independence, but the federal government wants to have some guidance. And so you want to have local control. People want to be able to change their Alteryx workbooks without having to check with anyone. You don't want to centralize everything. Tends to be a recipe for having bottlenecks. And likewise, the home office team wants to change something and know if they're breaking something that the self-service team does. The only logical way that you can do this is to encapsulate those things in a system. And then I can run this. So I can go in, and if I make a change on the back office stuff, I can see if the front office stuff worked. If I make a change in the front office stuff, I can see if I've created a regression. And so this centralization versus freedom, how to handle self-service analytics, I think is really important because it helps people collaborate better. And you know, I think that's a very important part. And even just setting up these kitchens for self-service teams can be incredibly important. How do they get the right data? How do they get the right tools? And managing your self-service users can also be a really important part. And you know, I can just show one customer example from that, just to be clear. And so there is a case where you know, one customer, you know, had this like case of how do I kind of reduce compliance across all my users? And you know, there's a bank. They had a big centralized IT resources, but they had people in New York doing loans, people in Texas, people in the Northwest doing branch banking, and they all sort of wanted different things. You know, they wanted the data that they wanted access to. They wanted their tools. And how does the central team have that? And so what we did is kind of give them, the central team, a set of tools to build these self-service sandboxes where they could kind of go in, encapsulates the data that they want, the tools that they want, and be able to see if they're doing anything wrong and then pull it back. And so that gives the central IT team some control over what the self-service teams are doing. And that's a good first step. But the second step is, how do you actually get the path to production? If I'm in Dallas, Fort Worth, and I've developed a good Python model for my high net worth individuals, and I start to run that week in and week out, I don't want to do that, right? How do I put that in production? How do I wrap that in a data ops blanket? Other cases, maybe you don't want it. Maybe you say that idea is so good that should be available to everyone. It should be an attributed dimension of your fact table, or it should be a materialized view that you have, or some other way to make it centralized. And so, you know, that, or other cases, it's, you know, you tried it, it works, and there's, you know, we just throw it away. So thinking about how the path to production of your self-service users, I think, is an incredibly important part to think about.
Chris?
So, yes.
I'm going to do a time check on you because I can see the guys from Google are getting on here.
Okay.
And so they can show their Google AI stuff, which we're excited about. How much longer you think you need to wrap?
How about 1 minute?
Okay.
So don't want to get in front of the Google AI guys. They do some cool stuff. So
Yeah.
the last thing I want to talk about is how you deal with, what we're basically saying is, man, there's so many cool tools out there. How you manage a system that runs those tools with the data you have and the people's important. And because we're data and analytics people, your system that you work in, the process that you deploy, the process that you run is actually a really good source of metrics. So how good is your source data? How often are things running on time or not on time? How well are your projects working and people working? There's a whole analytic opportunity to build. And that kind of goes into what the software teams call value stream management, really looking at all the sources of value and finding out where there's bottlenecks and get analytic about the analytic work that you're doing. And so our software has a whole module to support that. So, the summary here is at the end of the day is try to focus on the system that your team works in, the production process, the deployment process, how you collaborate in a centrally and decentralized way, and then how you measure your work. And by stepping back and focusing on these upstream problems, you're going to be able to better service your customers, be able to better deliver insight, and have more time to try out cool new technologies like AI.